Hello, and welcome to this week's Thursday Throwaway. It's going to be quite a short one this week, but what we're going to be looking at is tutorial 2 in the TECHNIA Tutorial Series, which involves this pin connecting a set of 3 lugs. As you can see from the feature tree, these are native geometry in 3DEXPERIENCE platform, so I've got a fully featured representation of these parts. And I've already applied some materials to them, so aluminium for the link and steel for the pins. So this is a fairly quick process in 3DEXPERIENCE platform. I'm going to go to the automated FEM part of the toolbars, open up the automated FEM tool and select advanced for my method of creating my mesh. For the procedure, I'm going to use a partition hex mesh with supports being all of the geometries. It's going to automatically partition any parts which are not able to be directly hex meshed. And I'm going to define the meshing by parameters with a target mesh size of 1.75 millimeters. And whilst I'm here, I might as well also have it create some solid sections because we've already got the materials applied to the parts. Just going to click OK here and click Run here. It's located 4 parts that it can mesh, and you'll see an assembly finite element model appear in the feature tree. And underneath, although they'll be hidden, it will create some abstraction shapes for the other parts, and it will then also create some finite element models for those. So in this case, there'll be 2 finite element models created, one for the link, which will then be shared across all 3 instances of the link, and one for the pin. And that is now done, and that's all there is to creating the finite element model. If we look here, we can see that the pin has automatically been partitioned for us. If I now update, we'll see the meshes start to appear. So the links are meshed and the pin is also meshed, and we can see it's a reasonably good mesh here on the pin. We might want to go back and modify that manually later, but for a first go at analysing this, that's going to be quite satisfactory. And that's all there is to creating the finite element model representation for this. We can see down here that we've got our FEM, and underneath we've got the nodes and elements here, and it's assigned a section to it automatically. And so that's ready to go and create the scenario and do the analysis, which I will look at in the next video in this series. Thanks for watching. Hello and welcome to this video. In this video I'm going to be carrying on looking at the TECHNIA tutorial number 2, finite element simulation. So in the last video I demonstrated how to create a finite element model on this geometry here, which is 3 sets of links joined by a pin. In this one I'm going to look at how we complete the finite element model up to the point where it's ready to solve. So click in the compass at the top left hand corner, and I'm going to use the mechanical scenario creation app for completing this process. So first thing I'm asked to do is prompted to select some details of the simulation. So a title, I'm going to call this one tutorial 2. The analysis type, which I'm just going to keep as general in this case, and the analysis case, which I'm going to call load X, something descriptive, and then choose the finite element model. So in this case, finite element model is only one to choose from. So I'll click on that and click OK. And at that point, we can see that these details have gone into the feature tree and the scenario load X has been created. So now I'm just going to use the visibility manager to remove the mesh and any non-contributing shapes, just to make it a little bit easier to select features on the model. First thing I'm going to do is create the procedure, which is going to be a static analysis step, and I'm pretty confident that the geometry deformations are going to be small, so I'll remove the nonlinear geometry option, but otherwise keep everything at the default values. Next thing I'm going to do is create some interaction details, because clearly in this model we're going to have contact between the links and the pin and the links and each other. So firstly I'm going to create a contact property, because I want to define friction in this model. So select the contact property toolbox and then define a coefficient friction of 0.1 and OK that. And then select the general contact option. And I'm happy with the defaults generally. I want it on all surfaces. And I'm just going to select that contact property I've just created as my default contact property and click OK. And then update that. Then I'm going to need to have some boundary conditions to fix the links in place. So we'll choose the clamp and choose these two faces here and OK that. And we can see they've been color coded just to show us that there is a boundary condition on there. And finally, I want to put a load on here, which is going to be a pressure load. So select pressure load and then just rotate the geometry around and click in here. And I want an outward pressure of 1 megapascal. And you can see when I type in there, once I click out of the dialog box, the units that I specified of megapascals are put into the default units of pascals. I can OK that. So as a general rule, we're often interested in solving more than one load case for a particular component or geometry. And in 3DEXPERIENCE platform, it's quite convenient because we can put many scenarios under the same model and they'll all share the same model and be linked back to it. So here I'm going to create a second load case. It's going to be very similar to the first one. So I'm just going to duplicate the first one using that option there. In this case, I'm going to be loading in a different direction. So I'll call this one load Z and OK that. And that's created a duplicate load case for me now. Again, as I say, it's all linked back to the same model. So any changes that I make to the model will be reflected in both load cases. The load case, or the load type, isn't quite correct for this. So I'm going to delete that pressure load, come back and put a different pressure load on here, which is going to be a traction type load. And I'll do 150 kilograms force acting in the Z direction for that. When I click out here, we get a glyph to show us the direction. That's OK, and that's all complete. Now when I move over to simulate, if I click in here to actually go ahead and do the simulation, click on the play button, we've got two load cases in here and we've got several different options about how we want to run them. So we can run them separately or concurrently as they're specified here. Obviously you need some external tokens in order to be able to run them concurrently. If I check that off, I can run them both with embedded licenses. And then when I click OK, they go off and run. So thanks very much for watching. I will conclude this series next week by looking at a bit of post-processing. But thank you for watching this video. Hello, and welcome to this week's video. In the previous two videos, we've been looking at building a finite element model and simulation scenarios for this pin and lugs geometry that's shown on the screen at the moment, concluding in the last video with starting the simulation. So that's now completed. And because we had two scenarios that we'd simulated, we've got two sets of results for it. So we can look at the time history of loading in the X direction, so pulling it in tension and bending the pin, and the second scenario of loading it out of plane of the lugs and bending something like that. So quite a nice situation here. We've got the feature tree with the model, and then we've got the two scenarios, and we've got the two sets of results all contained in the tree. And we can very easily inspect how we've loaded this geometry and what the results are for those. Very often, as an analyst, what happens next is that certainly initially the design doesn't always achieve exactly what it's supposed to achieve. And so we might want to go back and modify the design, or a designer might want to modify it and then have it reanalyzed. In the platform, the 3DEXPERIENCE platform, that's really easy to do. So we can open up the design geometry in a new app and give it a couple of seconds. That opens up, and then we can very easily go back in, all in the same software, and modify this model. So let's say, for example, we decide based on our stress results that the pin is not sufficiently big and we want to make it a larger diameter, then we can go in and open up the sketch. It just takes a couple of seconds to open up, and then very quickly change the diameter of that. So maybe we want to make it a 1/2 inch pin, and exit the app. And perhaps we also want a bit more bearing area on the lugs, so we can open up the lug component and maybe modify the pad so that it's extruded a little bit further. So if I double click on there a couple of times, it'll open up, and I'm going to make that an 11mm pad instead. So we're adding 1 millimeter's worth of extra thickness. You can see the geometry has changed immediately. The finite element model hasn't updated yet, but if I come back over to the analysis scenario, I'll go back into the model. Again, there's just a short delay whilst everything uploads. Now, hopefully when I update, we can see that the geometry changes and the finite element model is updated to include that, and then the pin should change a little bit as well because it needs to change its length to account for the additional thickness. So it's done that. So you can see it takes a short while to update, but actually it's highly automated. I'm not going to have to go in and change any other details in the finite element model to rerun it for this scenario. And within a very short space of time, it's done. So the links have updated the diameter of the hole to account for the new pin, the length of pin to account for the fact that the links are thicker, and then the mesh is updated. If I go into the scenario, we should be able to see that the boundary conditions and loads for each scenario have also remained correctly defined as they should be, and we will be ready to run this simulation again, all within the same software environment. So it's really convenient for updating the model and running various scenarios to make sure that we can actually achieve exactly the design goals that we want for the component. So that's all for this week's video. Hopefully that's a useful introduction to integrating simulation and modeling within the same domain. Thanks very much for watching.